Hi Robbie, thank you for your question. So for this question, we are going to use our heat equals mass times specific heat capacity times temperature change. And that formula looks like this when we add in the variables. Heat is given the symbol of Q, mass is M, always in grams, times our heat capacity, which is right there, times our change in temperature. The little triangle signifies change in temperature. Now, because we need to know what the final temperature is, I need to expand on this change of temperature. So what that becomes is Q is equal to mass times heat capacity times the change in temperature. And to calculate that change in temperature, it's T final minus the initial temperature. And for this question, we are looking for final temperature, so we need to figure out what TF is equal to. So what we're going to do is use algebra, and we are going to rearrange the formula to solve for temperature final. We're going to bring the temperature final over this side. We're going to put heat and bring it over to the other side and just rearrange this formula to solve for TF. And I can do that before I put any of our actual measurements or data into the equation. So I'll show you how we do that. First of all, you're always going to start with those things which aren't in the brackets. So we can't do anything with this until the very end because T final and T initial are closely related. So what we need to do first is bring the mass and the specific heat capacity over to the other side. So what we're looking at is, let's take the heat capacity first since it's closer to our brackets, and to bring it over to the other side, what we want to do is the opposite operation that's happening. So if we're multiplying by heat capacity, we want to divide both sides by heat capacity. So that's going to give us heat divided by specific heat capacity is equal to the mass times TF minus TI. Now the same thing we're going to do here is that we see that we want to get mass now over to the other side. So mass is multiplying TF minus TI, so the opposite of multiplying is going to be dividing. So we're going to divide both sides by mass, like that. Now I need a little bit more room, so I'm just going to bring it up if it will allow me. And now my, whoops, and now my mass cancels out just like it did up here with my heat capacity. And so now I have heat divided by heat capacity times mass is equal to T final minus TI. I can actually get rid of those brackets now, and the last thing I need to do is remove my initial temperature. So in order to do that, if I'm subtracting TI, if I'm subtracting my initial temperature here, to move it to the other side, I'm actually going to add initial temperature to both sides. That gets rid of my initial temperature here, and then when I go to rewrite my equation, it will be T final is equal to heat over capacity times mass plus my initial temperature. So you can solve for any of the variables within this equation just by rearranging the equation to solve for that variable using algebra. So you're going to have to polish up your algebra skills or freshen them up in order to do this rearranging. The next step then is to fill in your variables. So we're looking for T final. We have a 15-gram lead ball, so that's going to be your mass. It has an initial temperature of 25 degrees Celsius, so you can put the initial temperature here. It is heated with 40.5 joules of heat, so that's going to be Q, and then our specific heat capacity is 0.128, and that is going to be our C. So you can just go in and fill those in and then solve for your final temperature. Thanks again for posting your question, and I hope this video helps you in solving it. Bye for now.